Hello, I am Dexter and today I'll be representing the F16 group for this video demonstration. Okay, today I'll be presenting our project, the Community Medicine and Supplies Finder. Uh, this project is a community-driven web application that helps users to locate essential medicine and medical supplies in real time using availability information submitted by pharmacies, clinics, and community partners displayed on an interactive map. Okay. Uh, how did we come up with this idea together? The idea for this project was actually inspired by my family's experiences during periods of medicine shortages. During this COVID-19 period, there was a shortage of ART test kits, and my family had difficulty to locate them quickly. We had to visit multiple pharmacies, which was time consuming, stressful, and uncertain, especially when these supplies were urgently needed. Beyond COVID, we also face similar issues more recently. Our relatives overseas could not find Panadol soluble in Indonesia. They entrusted my family to buy it in Singapore, but we could only find it after going to a few pharmacies, and that was actually quite time consuming. These experiences highlighted a key problem to us. There was no easy way to know which nearby pharmacies still had specific essential medicines in stock, whether during a crisis or in everyday situations. Our website is designed for pharmacies and ordinary volunteers to update the website, which will inform residents on stock availability. To encourage pharmacies to consistently update, we could give them greater visibility, which in the future could possibly be extended to non-intrusive promotions on the website. Okay, so let's show you how the website works. Our website has two core functions: reporting availability and searching for supplies. Oh wait, I'm so sorry. This is searching and this is reporting. So first, pharmacies or vendors can submit an availability report through this report section here. They enter the medicine or supply name, category, stock status, store name, and optional notes such as quantity or time observed. Okay, let me show you how you fill in this form. Let's say I have Zyrtec. I'm a pharmacy worker and I have to fill in this form. So if I have Zyrtec here, it's a medicine. It's in stock and the branch is Guardian and Bugis Junction. This is maybe the quantity. And I will try to submit this form. But the website only allows you to submit the form if you have clicked on a map in a location on the map here. So why do we do this? This is actually to improve accuracy and trust. So we have integrated an interactive map using Leaflet. Before submitting a report, the pharmacy would select the exact store location on the map. This allows availability information to be geographically precise rather than relying only on text descriptions. Each submission here is timestamped, which also served as a form of lightweight advertising, showing users that a pharmacy has recently updated its stock status. Let's see how this actually works out. So let's say I have a pharmacy here. I'll put it here and I'll submit it. And it turns green because it's in stock. If I were to try a low stock item and put it here, it will be amber and red for no stock. Okay, let's see here. It's timestamp and you can see when the time is. I think this is actually quite good. So let's move on to the search section. Users can search for medicines or supplies using this bar here. So let's try Zyrtec. So they can apply this distance filter, such as 1 km, 3 km, or 5 km to quickly identify nearby pharmacies with availability. So let's try 1 km and you have to use this pointer, this blue pointer, to look for pharmacies. Like if you live in Yishun, you have to put it here. Unfortunately, we can only do this as I don't think we can do GPS. Okay, let's try and search. And all the reports go missing, which is correct. Because within a 1 km radius, you cannot find any pharmacies. But where did the pharmacies here go? Well, one intentional design choice we made is that when users perform a search, both the results list and the map are filtered together. This allows users to focus only on pharmacies that are relevant to their current query, reducing the visual clutter on the map. By hiding unrelated locations during a search, users can more quickly identify nearby pharmacies that are likely to have the items that they need. Importantly, the uh, underlying data is not removed, which actually would restore the information uh, when you clear the search thing. Like when you change it to a no distance filter, you see it comes back here, and it comes back on the map. Okay, so let's move on to another part, which is the confidence uh, indicators and risk analysis over here. So one major challenge that we have identified is that medicine availability changes very quickly, and a listing that was accurate maybe a few hours ago is no longer accurate and reliable. Hence, to address this problem, we have implemented confidence indicators based on how recently a pharmacy updated its availability. Listings are automatically labeled as high, medium, or low confidence, which encourages suppliers to keep their information current if they want visibility. So, as the time passes, the confidence rating will drop because the chances of the stock being there is lower. Beyond individual listings, we have also created a medicine supply shortage risk overview. Okay, so here, availability data is aggregated by medicine to indicate whether an item is at a low, medium, or high risk of shortage across the area. For selected medicines, such as common pain relief or allergy medication, we also display commonly used alternatives here. It's a drop-down list. However, as a disclaimer, alternatives should only be used as general reference. This drop-down list helps users to make more informed decisions rather than relying on a single store or product. On the technical side, the project is built using HTML, CSS, and JavaScript for the front end. We have used Leaflet for the geospatial mapping and browser APIs for timestamps, event handling, and dynamic DOM updates. All data updates also occur instantly in the browser, allowing availability listings, risk summaries, and map markers to refresh in real time. AI tools were used as learning references, and we use AI to help to enhance this website and cover the gaps that we did not understand on how to code. In conclusion, this project demonstrates how supplier updated availability data combined with mapping, real-time confidence indicators, and risk analysis can solve a real-world problem. Community medicine and supplies finder reduces uncertainty for users while giving pharmacies a simple way to advertise real-time stock availability to nearby communities. Thank you for watching and have a nice day.